Okay, so we have number 16. We have a substitution problem. We're going from 2 to 5 of the square root of x minus 1 over x dx. Alright, and they told us to use the u substitution of radical x minus 1. So if we were to do that, the question is what does that new integral become? They're not asking us to actually find the answer to this. Notice they just ask us to rewrite the integral in terms of u's. Well, knowing that that u right there is going to be on top, what do we have on bottom to get rid of? We have an x and we have a dx. Now, our du here, which is going to have to be introduced because in order to get a dx out of there, we're going to need to put a du in there. If we let our u be x minus 1 to the 1/2, then ultimately our du is going to be 1/2 x minus 1 to the negative 1/2 dx. No chain rule here because the derivative is 1. Okay? So right there we have our du relationship to dx, which if I write that more in the radical notation, I'd have 2 and then 1 x minus 1 on the bottom in the radical. So it looks something like that. So I'd have 2 on the bottom, and this would go down to the bottom because of the negative power and so on. And normally what happens is that when we replace our u with something here, we get something real nice here, but the bottom line is we don't have that in this case, do we? All right. So the question is, what are we going to do about that then? Well, keep in mind that somehow that dx has to go and somehow that x has to go, right? So if it's not a real nice substitution, then bottom line though is that we still just need to do the two options here. We need to get rid of x and we need to get rid of dx. Well, dx would be equal to that. If we just looked at the dx individually, wouldn't that be a true sentence then? Okay. What's this? Isn't that u? So wouldn't 2u du be equal to dx? True? And so therefore in our integral, we could get rid of that dx by replacing it with 2u du. So therefore we'd on top now have 2u du. And so we successfully have gotten rid of this and this. So now the only issue is what about that x? I'm going to get that x out of there. Is there anything that's x and u relationship? Don't we have one right here? Relationship between x and u. So ultimately wouldn't u squared equal x minus 1? And therefore u squared plus 1 equal x. And so we could put that there in place. And remember, keep in mind that the ultimate goal here is, a lot of them work out real nice and we don't have to do this, but bottom line is our main issue is can we get rid of the x stuff and bring in u stuff. And whether we have to do it all in one setting or we can do it in parts, okay, we still have successfully gotten it done. So ultimately our new integrand is this. Alright, now if you look at the integrand options, okay, that looks like it could be letter A or it could be letter E. So how do we choose between which one is the correct one, either A or E? What's the difference between A and E? Yeah, the limits are different. Okay, ultimately, if I had this equation right here, is it okay to take the 2 and the 5 and just put them in there for the u values? No, because those are not u values, they're x values. So what do we need to do to the u values, or x values? We need to make them into what? Into u values. If I put a 5 in here, I'm going to get 5 minus 1, that's 4. Square root of 4 is 2. And if I put a 2 in there, I'm going to get 2 minus 1, that's 1. Square root of 1 is 1. And therefore, which one is correct? E. Good problem. Questions on any part of anything I did there? Next. Yep. 18. On 18 we have integral from 0 to 2 of 2x cubed minus kx squared plus 2k dx equals 12. And we want to find the value of k here. Well, ultimately the left side is just a definite integral, so we can find an answer for that by using the fundamental theorem. So if we do the 2x cubed, it's going to be 2x to the 4th over 4 antiderivative. This is going to be negative kx cubed over 3 plus 2k here. Remember, it's just a constant, so that's going to just be 2kx. Evaluate that on 0 and 2. And let's see what we get. If we put a 2 in here for x, we're going to get, on top, we're going to get 16. 16 divided by 4 is 4. 4 times 2 is 8. If we put a 2 in here, we're going to get 8/3 k. And put a 2 in here, we're going to get plus 4k. And then we're going to minus 0 in here, but notice that all these parts have zeros, or all these parts have x's, so 0 is just going to give me 0. So bottom line here is, if we simplify this, this would be 12/3. So 12/3 and negative 8/3 would be 4/3 positive. So it would be plus 4/3 k if we simplify those, and that has to equal 12 then, right? So if we evaluate the left side, what's the only variable? Okay, so if we solve that, we're going to get 4/3 k equals 4. And if we multiply, we get 1/3. No, did it backwards. 3, not 1/3. 3 is on top, 4 is on the bottom. So. Alright. Questions on any part of number 18? Next. All right. On number 20, we have that x is less than 1, they tell us, and they told us that y is equal to ln of the square root of 1 minus x squared, which is good that x is between negative 1 and 1, because if we put anything bigger than 1 in here, we're going to get a negative under the radical. Okay. Anything less than negative 1 is going to be a negative under the radical, so this being our domain. And bottom line here is that we just want to know the derivative of this. So if I want to find y prime here, recognize that it's a composition here, because we have a natural log of something, and the something is not x, so therefore outside function is natural log. Derivative of natural log is 1 over the argument times what? Times the derivative of the argument. And the derivative of the argument in this case, which will go in this blank in a minute, if I write it as 1 minus x squared to the 1/2, the derivative is going to be 1/2, 1 minus x squared to the negative 1/2 times negative 2x. The derivative of the inside is negative 2x. So ultimately the 2's will cancel out. We'll have negative x on top, radical 1 minus x squared on the bottom. Alright, and so if we take that and put it in the blank that we left for it, we multiply those two together, we get negative x on top, and then what's going to happen on the bottom? Those are both the same argument, aren't they? So radical times radical will make that radical what? Go away, so we get 1 minus x squared. Alright, so looking at our choices though, that's not there. So are we wrong? Okay, not wrong, necessarily. Okay. Before you think you're wrong, okay, see if you can do something with it and make it look like one of the other ones. Multiplying by negative 1 over negative 1 would give us x on top, and it would make these two switch then, wouldn't it? One of them positive, one of them negative, opposites. So ultimately it would be letter B. Next. 19, we have secant squared x, tangent squared x, dx. Alright, ultimately this is not a known derivative. We could try to manipulate. One thing that I'd recognize though is here is that if we let tangent be our u, wouldn't the derivative be secant squared? So let's try that. That'd be my first option here, to let the secant squared x dx be part of our du expression, which means our substitution might be fairly clean here. And remember, when I have tangent squared x, this means tangent of x all squared. Okay? So therefore my new integral would be just u squared du then, wouldn't it? Right here would be replaced by u squared. Secant squared x dx would be du. And so that would be my integral. So my answer would be u cubed over 3 plus c. And ultimately it would be tangent x all cubed over 3 plus c. And that would match up with choice A. Next. 26 says we have a normal line, which we know is a line that's perpendicular to the tangent line. So we got a normal line to the graph of this function at point x. F of x is defined to be the line perpendicular to the tangent line, which we already knew that, but bottom line here says an equation for the line normal to this graph at the point where x equals 3 is what? So the equation we got is the cube root of x squared minus 1. So in other words, find the derivative here, because we need to find the equation for the tangent line first, because if we can find that equation, or if we can find at least the slope at that point, we know the normal line will have opposite reciprocal slope. So I'd rewrite this as x squared minus 1 to the 1/3 first. So our derivative would be 1/3 x squared minus 1 to the 1/3 minus 1 would be negative 2/3 times 2x, the derivative inside. So ultimately I'd have 2x on top, I'd have 3, and then on the bottom I'd have the cube root of x squared minus 1 all squared as our derivative. So that's our y prime. And the point in question here is we want the slope when y is, or when x is 3 it says. So if I put my 3 in there, let's see what we get here. 3 cube root, 3 squared, minus 1, all squared. Alright, so doing the math on that, slope-wise we'd have 6 on top. On the bottom, if we did 3 squared minus 1, that'd be 8. 8 squared would be 64. And the cube root of 64 conveniently is 4. So we'd have ultimately a 12 on the bottom. We have 3 here. This whole thing would be 4. Again, this is 8 in the parentheses. 8 squared is 64. Cube root of 64 is conveniently 4. And therefore our slope would be a half. Now remember, that's the slope of the tangent line. So what's the slope of our normal line that we're looking for? Opposite reciprocal would be negative 2. And from here, if we want to write our equation, then we can fill in our blanks at this point. What's the one thing that we need to know, though? We know x equals 3, so we can plug that in. We also need to know our y value, don't we? And the y value is going to come from the function, so if we put a 3 in there, we're going to get 8. Cube root would be 2. Would be y minus 2. And again, looking at our answers, is that a choice? Nope, they put them in standard form here, somewhat standard form. So ultimately, if we do negative 2x plus 6 over here, move our x, we get x, 2x plus y, and then over here we get 8. Looks like that would be letter D. Would be the matchup. Questions on any part of that one? Next. 16 through 30. We have an equation that says y equals e to the 2 minus x. And it says at the point 1e, so it says the tangent line to this graph at the point 1e intersects both coordinate axes. And we want to know what is the area of the triangle formed by the tangent line and these coordinate axes. Okay? So if we figure out our equation for that said line, then we can figure out its x and y intercepts and therefore figure out the area of the triangle. Okay? So if we are going to write the equation for it, we know that it's going to be y minus e and then x minus 1 because it goes to the point 1e, we know. And so ultimately we need to know what's the derivative because that's going to give us our slope for this equation. So the derivative here is going to be itself times the derivative of the argument. So it would be negative e to the 2 minus x. Again, the derivative of 2 minus x would be negative 1. Alright, so at that point, which is 1e, if I put a 1 in here, I'm going to get negative e squared. Put a 1 in here. I'd have e to the, not e squared, it'd just be e, sorry. 1 in here would give me 1 as my power, so it'd just be negative e then, would be the slope. Alright, and so if I put this in the right form here, negative ex plus e, and then I get it in slope-intercept form, I'd have plus 2e over here. Ultimately that 2e right there would be my y-intercept. So I'm thinking of that picture-wise, it'd be somewhere 2e here. Would be my y-intercept. My x-intercept would be where the y equals 0. So if we solve this, we'd have negative 2e equals negative ex if I put a 0 in for y and solve for x. So dividing, I'd get simply 2. divide by negative e on both sides. So that means 2, 0 would be my other intercept. And ultimately the issue is, can I find the area of that triangle? 1/2 times 2 times 2e would be the result then, wouldn't it? That's my base and my height there for that triangle. So ultimately it would just be 2e, should be letter A. Questions on that one?